With equilibrium, we spend a fair amount of time using the equilibrium constant to tell us information about concentrations. And now we're going to put it into practice. The practical side of this is dealing with acid and base equilibrium. In particular, using some of the shortcuts that we picked up in our discussion of equilibrium to directly relate it to specific types of solutions. So for this, we're going to deal heavily with acid-base equilibrium. And central to this concept of acid-base equilibrium are pH, pOH, Kw, hydronium ion concentration, hydroxide ion concentration, all of which are all interrelated, and we'll show that. So we're going to spend a lot of time talking about acid-base equilibrium. We're going to discuss weak acids and weak bases, because when we deal with weak acids and weak bases, what we're dealing with are equilibrium situations. When we deal with strong acids and strong bases, we have to take into account their chemistry, but usually their solutions are much more straightforward. But weak acids and weak bases, these are actually equilibrium situations, and so there will be significant amounts of both starting materials and products present. And related to this is this idea of the conjugate acid-base relationship. Weak acid, any acid, when it undergoes deprotonation, becomes a base, and so we'll have to that'll be very helpful in discussing our behaviors. And these are intimately tied to Ka and Kb. I apologize, there's no subscript under this program. So these Ka and Kb are just equilibrium constants associated with the particular acids or base, and I'll let you guess which one is acid and which one is base. And we're going to use this information to do exactly the same type of thing we did with equilibrium constants. We're going to use concentrations to predict Ka and Kb, and vice versa. We're going to use Ka and Kb and initial concentrations to predict concentrations at equilibrium. The problem is that we're often not looking, we don't exactly necessarily state, we being me and my multiple personalities, don't exactly state what the, if I'm asking you for pH, what you need to be looking for is not pH, but hydronium ion concentration, etc. So there's this interrelationship that we have to be able to swap freely. Associated with this, and to help describe, you have to sort of conceptualize what's actually going on when we neutralize a solution and when we deal with predicting pHs of salts. And these will all be tied to buffers